Good evening viewers, and you are welcome to my channel. And today we are going to discuss a question which was saying that develop a C program that can find the roots of a quadratic equation of a form x squared plus bx plus c is equal to 0. And the conditions they gave us is that our program should be able to handle real and complex roots. So now let's dive into the code. So now, as we are coding, we are going to first interpret the question. They told us that the program should prompt the user to enter the coefficients a, b, and c, and we should validate the input to ensure that a is not 0. So what we shall first do, we are going to first initialize the headers, where we shall start with the include stdio.h. This is a header file in C programming that stands for standard input-output header. It provides functions for input and output operations such as reading from the keyboard, that is specially done by the scanf, and the printing to the console, that is done by the printf. So now we enter include stdio. Then the other thing we have to add is the include math.h header. Now this include math.h, it is a header that enables you to gain access to mathematical functions and constants like SQRT, which is the square root, the sine, which is sine, and cosine, exponential, and many others. Now after typing those, we start writing our code. We start with the int main. Then as our question was saying that the program should prompt the user to enter the coefficients. So we first remember you're handling a float, so we first write float a, b, c, d. D is the discriminant. Let us not forget that d is the discriminant. R1 is root 1, R2 is root 2. And since I'll explain what R1 really means and R1 MIG means later. Now, as the instruction was saying that the program should prompt the user to enter the coefficients, so this is what we do. Printf, remember, allows us to print to the console. So it is going to allow us to input our coefficients. So we type printf, enter a, b, c, and scanf. Scanf, what it does, it allows us to read from the keyboard. So %f, 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 and a, and b, and c. So we continue. Now we have finished the first condition. Second question was saying that validate the input to ensure that a is not 0. So make sure to do that we use the if condition. We use the if control statement, and we shall say that if a is equal to 0, printf coefficient a must be a non-zero, else it will return 1. That means it will raise an error. I hope you get me. Now the next condition we have was implement a function to calculate the discriminant b squared minus 4ac. So now d is our discriminant. So now we are going to do that, where d, we have to implement that a function to calculate the discriminant, which is going to be d is equal to b times b minus 4 times a times c. Then after print the discriminant. Depending on the coefficients which you have input, it will calculate and give you the value of the discriminant. I hope you get me there. Of the syntax, if you learn very well C, you can clearly understand it. Now, the other instruction was, depending on the value of the discriminant, determine whether the roots are real and distinct, real and equal, or complex. That is another thing which the question is telling us. I repeat, depending on the value of the discriminant, determine whether the roots are real and distinct, real and equal, or complex. Now, if we know what real and distinct roots are, this is what we shall do. For real and distinct roots, print if real and distinct roots are roots where the discriminant is greater than 0. As long as the discriminant is greater than 0, those roots will be real and distinct. Hope you get me. And now, print f it shall print, as long as it satisfies the condition of the discriminant being greater than 0, it shall print this. But then we need also to find the roots. The roots 1, roots 2. So root 1 will be negative b times plus square root of the discriminant divided by 2 times a. Root 2, what changes is the sign. If we remember the bulldozer formula, which is negative b plus or minus square root of b squared minus 4ac divided by 2a, which is basically what we're doing here. But the first root will be a positive, the second root will be a negative. And so after it will print the roots, to print the first root and also print the second root. Now the other condition will be for the real and equal roots. Hope you get me. So roots are real and equal if the discriminant is equal, exactly equal to 0. Hope you get me there. So if the discriminant is equal to 0, if you remember that means that square root part on the bulldozer theorem will be equal to 0. So that's why the first root, it will be negative b divided by 2 divided by a, and it will be the same because the discriminant is equal to 0. So there is no part where you shall facilitate the plus or negative sign. And so same thing, it will print the first root and the second root. If at all it has satisfied the condition of the discriminant being exactly equal to 0. Then the third condition, they told us that the roots should be real and distinct, that is done, real and equal, that is done, and then we're left with complex. So remember, you're using the if contrast statement, so it will allow us to use also the contrast statements of else if, and then lastly we shall allow us to use else as the syntax goes, because similar to what we are using in Python. So the printf roots are complex, that's what it shall print. Then the first root, remember in complex roots, if you remember very well our mathematics, the roots are real and imaginary. But now you have two roots, you have to prove two roots. The first root 1 and root 2, and root 1 and root 2 both have the imaginary and the real part. So for the real part, the determinant is 0. That's why it's negative b divided by 2 times a. Then r1, the imaginary part, negative b is equal to 0. Then we square it is equal to square root of the determinant divided by 2 times a, which is the same for root. Okay, let's continue where I stopped, which is the same for root 2 and the root 1 and root 2. So after that it shall print the first root. If at all it is real, it shall print the real and the imaginary part. And then after all this, the root shall return. We shall return 0 at the end of our code. So now let us try to run the code and see if it has run. So let us first try to proofread our code and see how it shall go. So this is it. Int main, yeah, that's it. So yeah, that's our code. Okay, now let us try to run the code. Then it says it has compiled successfully. Now we are going to try to input our coefficients. So you're going to input 1, and then after input 1, you don't follow this order, but you just press enter, and then you put a second coefficient shall be in place of b, and then you put a third coefficient shall be in place of c, which is 10, and then we enter. Then what it shall first print, according to our code, it shall first print the discriminant, because we have prompted it, we have entered the coefficient. Now it shall first print the discriminant. So after printing the discriminant, it shall use that discriminant to go through these conditional statements or control statements to find which one of them fulfills the condition. So now -6, -36. So now that is obviously the roots are real and copies, because it's not greater than 0, it's not equal to 0. That means it's got to print the else part, which is not none of the above condition, which is roots are complex. So that's why it prints the. Then now it goes on to calculate the roots, which the real roots, the real first root, which is. This is the real part, this is the imaginary part. This is the real part, this is the imaginary part. Hope you get me. So now let us try to run again and put other coefficients. You're going to put 1, then you're going to input -4, and then we shall also put other coefficient, which is going to be in the place of c, which is 4. So now it has first calculated the discriminant, as we had discussed in the previous one, the discriminant. So it has used that discriminant, and that discriminant is exactly equal to 0. So it is going to go through these conditional statements or control statement to see where this condition is, which is the else if b is equal to 0. So it's going to first print the roots are real and equal, because it follows the syntax. They can't just jump. So now after, it is going to calculate the roots because it has already satisfied this condition. So it's going to use the coefficients that you have brought to calculate using the roots, the formulas of the roots which are under this condition of d is exactly equal to 0. So it gets the first root as 2.00, the second root which is also 0.0. So that's basically our program, and I think this program, it is basically helping us to find the roots of a quadratic equation. And that's it. Thank you very much. See you next time.